So this is my recommendation to you. Be present in the classes. Start studying right now. Okay, because after mid semester you'll be able to understand that it's not that simple to score the same marks which you have gotten in plus 2 class. Okay, anyway, let us come back to the class, and I'll start screen sharing with you. Okay, can you see my screen?
Yes,
Yes,
sir.
sir.
Okay. So last time we have started discussing about JFET. Okay, so this is something what we are studying, and Okay, can you see the screen in the right side?
Yes, sir.
Yes, sir.
Sure. Right. So this is a JFET. Sorry, junction field effect transistor. Second, hold. Okay, so this is the structure. This is dono side P junctions. Okay, and both are shorted actually. This is source. This is drain. Right. Source means source of electrons. Drain means where electrons will move. And this is gate actually. This is gate. This is also gate. Right. So this is something which we can say is this is shorted. Okay. Means both points are same basically. Right. So this is these are ohmic contacts, means metal contacts are there. They are like wires actually. Aluminum wires रहते हैं generally. And this is M semiconductor. This is N semiconductor in between. So this is something like PNP type. ऐसे दिख रहा है ना, but it's not like that. It is also unipolar. मतलब और BJT we know that it is something like this. ऐसे. Okay. And PN like this. This is BJT, emitter, base and collector. तो BJT ऐसा है तरह से. Okay. So there are certain situations which you can see here. Or if we go for this condition that the working of this junction field effect transistor, this we need to understand actually. Right now, if you go for this, right, this is source. Okay, now talk about this. This is something what we know. Okay. Now what we do is we know this is gate. इसका short करते हैं. गेट को शॉर्ट कर दिया. राइट. This is drain. This is drain with us. We apply some potential here. Okay, that is VDD. right? It means this is variable, positive potential here, negative potential here. This is connected with ground, you know. Okay, and this VGS is also zero. Means both are connected with ground. This is also at the same potential ground. So VGS is zero and VDS is positive. This is the first condition which we are taking. So if this is positive potential, it means it is going to attract the electrons like this. Electrons will move like this. Am I right? Electrons from N-type semiconductor will move like this. Gate and source, they are zero, at zero potential. So there is no flow of charge. Am I right? VGS is zero means current is zero. Gate current is zero, or gate to source current is zero. That is what we can say. But when we are applying VDD, we are applying, so there is flow of charge carriers like this. And if electron is moving like this, current is moving opposite to that direction. So this is current ID. Okay. And if you see, this is nothing but this is N. हेलो
हेलो
हाँ जी
नमस्कार जी
हाँ जी नमस्कार जी
सर राजकुमार जी कर रहे हैं बात
नहीं नहीं सॉरी okay so this N is connected with positive and this P is connected with ground basically. So this is a reverse bias, isn't it? If N is connected with higher potential and P is connected with lower potential, means this is connected with ground and this is connected with positive VDD, sorry. So this is reverse bias, right? So there will be depletion layer here, like this. If this is VDD, suppose this is 10 volts, so this 10 volt is higher here and this is ground. Means यहाँ 10 है तो यहाँ 9 होगी, 8 7 6 5 4 3 2 1 0, like this. This is how potential is coming down, and accordingly reverse bias is also coming down. Okay, ठीक है?
Yes, sir.
So that means it is something like a resistance here basically. ये resistance की तरह है. If you see figure 6.6, can you see it?
Yes, sir. Yes, sir.
है ना? So it means यहाँ अगर 10 volts है ऊपर और यहाँ 0, it means potential is dropping from here to here. So reverse bias भी drop हो रही है ऊपर से नीचे तक. That's why this extra portion which is here, ये depletion width है. When you apply it like this, ठीक है? And the current is flowing across this because of this VDD, right? So if you increase this VDD, That means you are increasing this point. हम क्या करेंगे? Okay, now coming back to this. Okay, if you see this, as you increase this voltage, suppose it is initially 5. If I am increasing it from 5 to 6 to 7 to 8 volt to 9 volt to 10 volts, is I am increasing this VDS, this voltage. What is going to happen is I'm going to increase this reverse bias like this. ऐसे है ना? And if I increase the voltage, it is further increasing like this, increasing like this. So if you see, its shape is something like this. ये सोर्स है, ये ड्रेन है, ऐसे हो रहा है ना? This is depletion layer. This is nothing but this is depletion layer. Okay, and we are applying here some voltage, and electrons are flowing like this, and accordingly we have current here. अगर आप ये देखो, ये क्या है? हेलो,
फनल।
फनल है ना?
फनल।
हाँ, तो इसमें क्या है देखो, मान लो आप ऊपर से पानी डाल रहे हैं या तेल डाल रहे हैं, राइट? इट इज कमिंग आउट, नीचे से आ रहा है. ओके, अगर यहाँ इसको पूरा भी भर दो तो क्या होगा? नीचे क्या रहेगा? कांस्टेंट
नीचे
रहेगा.
कांस्टेंट है।
ठीक है, तो यहाँ भी वही सिचुएशन है दैट इवन इफ यू इंक्रीज दिस वोल्टेज, तो ये फनल जैसी रहेगी. ओके, तो यहाँ एक कांस्टेंट करंट ही फ्लो करेगा हमेशा. दैट्स व्हाई कैरेक्टरिस्टिक्स, इफ यू सी हियर in the right side, at VGS is 0, this is current ID and this is saturation. So initially क्या है? ये लीनियर है, लीनियर और एक्टिव. और जब ये when it is reaching up to pinch off means this situation, ये pinch off है एक तरह से. Okay, right? So this is at VGS is equal to 0 volt. Understand कि ये saturation में कैसे गया? इनिशियली व्हेन यू इंक्रीज द VDS करंट बढ़ेगा, ये बढ़ रहा है ना इनिशियली, ओके। और एक सिचुएशन ऐसी आएगी जब ये व्हेन दिस रिवर्स वाइज इज एक तरह से फनल वाली शेप बना देगा, ओके। देन इट स्टार्ट्स फ्लोइंग ए कंटिन्यूअस करंट, कांस्टेंट करंट फ्रॉम हियर, so then it is becoming constant here, अब ये constant हो, right? Understand this point now, why this is moving into saturation and this is moving into pinch off, and this current at which this is becoming constant, it is IDSS, okay. Can you see the situation pinch off in the right side, figure 6.8,
Yes, sir.
है ना? तो फनल की तरह बन गया एक तरह से। पिंच ऑफ मीन्स सिर्फ एक चुटकी भर जाने के लिए बचा, पिंच मीन्स चुटकी ना,
Yes, sir.
हाँ, तो बस वही बात है कि उतना बस चुटकी लाइक, ओके। किसी को ये बात समझ ना आई हो? That what is the working of this JFET? I hope you will be able to understand now. तो हमने क्या किया? We have fixed this VGS 0 and we have just varied this VDD और VDS, कुछ भी बोल सकते हैं, okay, fine. And IDSS is, this IDSS means it is the maximum current, maximum drain current of JFET. JFET at VGS is 0 volt and VDS is greater than pinch off voltage, because this is pinch off. After pinch off, this is going to increase. So this is what I have taken from Boylsted. You can have this book online, okay. तो ये फर्स्ट कंडीशन थी। कंडीशन क्या थी? VGS 0 है and VDS positive. Now second condition is, if VGS is greater than, less than 0 volt, okay, and we are applying certain VDS positive, तो क्या होगा? This is P, this is P, okay. We are applying this as negative. तो ये VDS है, ये पॉजिटिव है, ये नेगेटिव है, that means ID current is flowing like this. This is negative, but because this VGS or this VGS we are applying is negative, so this negative is going to make this PN junction, because P is connected with lowest, so definitely we have, or what should be this IG current? Because it is reverse bias, तो ये reverse bias रहेगा ना इसकी वजह से। ये पोर्शन जो है, दिस इज डिप्लीशन लेयर, ऐसा ही हो जाएगा।
Yes, sir.
ओके, बिकॉज दिस इज रिवर्स वाइज. ये भी गेट है और ये भी गेट है, तो ये रिवर्स वाइज कर रहा है इसको बेसिकली. इफ वी अप्लाई दिस वन, right? So this is also reverse biasing it. It means if you apply this reverse bias, and now we are increasing this VDS, इस VDS को भी इंक्रीज करते हैं मान लो, तो ये भी रिवर्स वाइज में हेल्प करेगा. सो VGS नेगेटिव and VDS positive will make PN junction reverse bias. Okay, तो saturation क्या होगा, जल्दी आएगा because depletion width जल्दी बनेगा as compared to VGS 0. VGS negative जो है make this PN junction more reverse bias. So the pinch off we are getting is earlier than VGS is equal to 0. Pinch off means this situation. This situation. This is pinch off. Like this. तो ये pinch off बन जाएगा ऐसे. Because this is also helping in a reverse bias. This negative potential. Okay. So characteristics now will modify towards this side. If you go for this, so अगर VGS ऐसे था, this is VGS is equal to 0 volt. This is, and if VGS is -1, so I am getting this earlier. If VGS is -2, okay, so this is pinch off actually, right? So this VGS is helping in attaining the pinch off, and reverse wise it is having earlier. So VGS 0 volt के बजाय VDS, this voltage like this. I hope you understand this point now. This is ohmic, linear or active region. तीन नाम है. Ohmic means resistance type behavior है basically. That's why ohmic. This is saturation. Understand this point? Hello?
Yes, sir.
क्या
Right?
एक बार फिर से बता देंगे?
You just see this. VGS is negative.
Yes, sir.
अगर VGS नेगेटिव है तो PN जंक्शन है, ये वाला PN जंक्शन है ना.
Yes, sir.
इसको क्या करेगा, रिवर्स वाइज करेगा या फॉरवर्ड वाइज करेगा? रिवर्स वाइज करेगा. इट मींस ये डिप्लीशन लेयर बनाएगा इधर. ओके, तो VGS नेगेटिव से रिवर्स वाइज बनना शुरू, डिप्लीशन लेयर बनना शुरू हो जाएगा. और इस VDS से भी, क्योंकि ये पॉजिटिव है, तो पॉजिटिव इज कनेक्टेड विद दिस N, राइट? ज्यादा पोटेंशियल पे है ना, और ये ग्राउंड पे है,
Yes, sir.
तो दिस एनपी जंक्शन इज ऑल्सो रिवर्स बायस, ये भी उसी रिवर्स बायस में हेल्प कर रहा है। ठीक है, ये वैसे ही है जैसे मान लो रस्सी है एक, ठीक है, कि अब रस्सी को आप इस साइड को खींचना शुरू करो, 1, एक तरह से ये बीडीएस है, एक और आया वो भी इसी साइड को खींचना शुरू कर देगा, तो नेट रिजल्टेंट एक साइड को रहेगा ना, कि
Yes,
दो
sir.
लोग रस्सी को एक साइड को खींचना शुरू कर देंगे तो खिंच जाएगी, बट अगर एक अपोजिट डायरेक्शन में करेगा, अपोजिट में करेगा, तो इट वॉन्ट बी पॉसिबल। तो यहां भी वही है, बिकॉज दिस इज एनर्जी, सोर्स ऑफ एनर्जी। सो एक वीजीएस है, एक वीडीएस है बेसिकली। तो अगर दोनों ही रिवर्स बायस में हेल्प कर रहे हैं तो समझ लो हमें सैचुरेशन जल्दी मिलेगी। क्यों? बिकॉज दिस पिंच ऑफ वी आर having earlier than any other voltage, okay, as compared to 0। तो ऐसे हो, आई होप यू अंडरस्टैंड नाउ।
Yes, sir.
ये है ना, ये P है, ये P है। अगर इसको रिवर्स बाइस कर दूं मैं, ठीक है, और यहां से VDS लगा रहा हूं एक में, तो ये पॉजिटिव से आ जाए, ये N है, ये नेगेटिव है, तो ये वोल्टेज भी रिवर्स बाइस कर रही है और ये वोल्टेज भी रिवर्स बाइस कर रही है, ओके। देन यू विल अटेन दिस पिंच ऑफ रिवर्स बाइसर अर्लियर। ऐसे करोगे ना तो ये सैचुरेशन में चला जाएगा एकदम, राइट। इफ आई डू द अपोजिट, कि इसको पॉजिटिव कर दूं, तो क्या होगा? इफ VGS इज पॉजिटिव, सो PN जंक्शन क्या होगा?
Forward bias.
Forward
Forward
bias.
bias. It means
फॉरवर्ड वाइज
you are not getting it,
लेट आएगी।
late आएगी। So this is at VGS is 0, VGS 2 वोल्ट पे है, VGS -2 पे, and this is pinch off, right? This is VDS. I hope it is clear to you now, okay? So this is how it works actually, right? And if you increase this voltage beyond certain point, इसको मान लो 25 वोल्ट के बियॉन्ड आप अप्लाई कर रहे हो, सो इट कैन ऑल्सो गो इनटू breakdown. Large amount of current will flow, right? So this is called as breakdown, right? Okay, hello?
Yes, sir.
Because
Yes.
large amount of current will flow and it can damage our device. Fine. And this is the symbol of the device. This is N channel. अभी हमने N channel नहीं पढ़ा मतलब ना, ठीक है, and this is P channel. And if you see, in case of BJT, IC is equal to beta IB, and in case of this, ID is equal to IDSS 1 minus BGS by BP whole square. Okay. So this is called as Shockley's equation, right? So Shockley has invented the field effect theory, and he helped in the formation of transistor and FET both. So here, if you see, this ID is dependent upon this BGS. Am I right? Okay. And here IC is dependent upon this IB. So that is the difference that between these two devices. This is current controlled, current driven device. This is voltage controlled, current driven device. So when VGS is 0 volt, ID is equal to IDS. This one. This is IDSS. Okay. So when VGS is 0 volt, if I put here VGS is equal to 0, this is what I'm getting. Okay. And VGS, if I try to find out, it is becoming equal to VP 1 minus ID by IDSS. Okay. So this is how we can find out. And this RD, इसमें RD भी दिया हुआ है जैसे अब if I see here, yeah, dynamic resistance is equal to resistance as 0 volt, like this. These are few of the formulas which you can use. So this is the transfer characteristics actually, is input versus output, or BGS versus ID actually. Means when BGS is 0 volt, okay. So this is IDSS, right? यही बनाया था ना हमने. And this is pinch off. So current is like this: 1, 2, 3, 4, 5, 6, 7. So this is the reason of you can see. And this is pinch This is very important if you see. Okay. So we have this IGSS, or IG is generally 0, lagbhag. If you see, it is approximately 0. And we have another parameters also. ये दे रखा है जैसे characteristics दे रखी है ना at 25 degree centigrade. That how it looks like. Gate source voltage दी हुई है, capacitance दी हुई है इसकी, ratings, yeah, thermal characteristics also. Because power dissipation here is that is equal to PGS VDS by VDS into ID. That is for JFET. Or if we talk about BJT, it is VCE into IC or BJT. Okay? So these are the you can say the thermal characteristics.
सर बुक का लिंक क्लासरूम में भेज दीजिएगा ना सर।
ये जो है बुक का लिंक पढ़ लो आप ऊपर rtna.ac. बॉयलस्टेड की बुक लिखो आप, उस पे अपने आप आ जाता है लिंक, PDF ऑफ बॉयलस्टेड, है ना?
ओके सर।
ओके, शेयर कर दूंगा मैं, वो कोई दिक्कत नहीं है। So yeah, this is what you can see now. Can you see equations of both the things? So drain current is equal to source current here. Gate current is very very small because it is reverse wise. तो reverse wise में सिर्फ एक ही करंट फ्लो करता है. Which current? PN जंक्शन जब रिवर्स वाइज होगा तो कौन सा करंट फ्लो करेगा?
डिफ्यूजन करंट। डिफ्यूजन करंट।
ये नेगेटिव है, ये पॉजिटिव है. सो यहाँ पे होल्स होते हैं ना, और यहाँ इलेक्ट्रॉन्स भी होते हैं. माइनॉरिटी करंट, holes will attract towards this side and electron will attract towards this side. Okay, so this is the current because of minority carriers. Right, जिसको लीकेज करंट भी बोलते हैं. Even if it is reverse bias, तो यहाँ डिप्लीशन विड्थ है, होती है ना इसमें. और रिवर्स करोगे तो और डिप्लीशन विड्थ बढ़ेगी. But we have minority carriers also, so that current is flowing because of the minority carriers. So this current is very small, 10 nanoampere है जैसे. Okay, कम है because minority carriers कम होते हैं. N साइड में होल्स कम होंगे, P साइड में इलेक्ट्रॉन्स कम होंगे. Okay, so next class we'll talk about MOSFET. Next is MOSFET, metal oxide semiconductor field effect transistor. ठीक है, इसको कल करते हैं. अभी हम बात करते हैं इसकी जरा. लेट मी सी, कोई न्यूमेरिकल है? Okay. Okay. Any questions from today's class? Anji? Hello.
No, sir.
No, sir.
Here? So I hope you understand now that how the FET or this junction field effect transistor is going into saturation. So difference between BJT and JFET, if we see, so BJT is IC is equal to beta IB. Here it is equal this ID is equal to IDSS 1 minus BGS by BP whole square. Okay. So here we have IC current, and here we have ID is equal to IS. Gate current is very small, 0. Okay, 0 ampere, sorry. And here this is IC versus IV. Here it is ID versus VGS. Okay, and if you see here, it's working here, this one. So because it is becoming a reverse bias here, reverse bias हो रहा है ना, so इसकी input resistance भी क्या होगी? रिवर्स बायस में रेजिस्टेंस ज्यादा होनी चाहिए, कम होनी चाहिए? ज्यादा होनी चाहिए. ओके, सो इज हाई. इसमें इनपुट रेजिस्टेंस लो है बिकॉज दिस इनपुट रेजिस्टेंस इज फॉरवर्ड बायस. ये फॉरवर्ड बायस रहता है ना हमेशा, और ये रिवर्स बायस. ओके, तो इनपुट रेजिस्टेंस हमेशा कम रहेगी इस केस में, और इस केस में because this is reverse bias, suppose. So what should be the input resistance? Because this is 0, so input कितनी होनी चाहिए? बहुत very high input impedance, isn't it? Because ये reverse bias है ना, reverse bias. ओके,
Yes, sir.
तो इसका फायदा क्या है इनपुट रेजिस्टेंस हाई होने का? कि कोई भी नॉइस सिग्नल जो है वो इजीली ऐड नहीं हो सकता. Noise can't be easily added into JFET. FET. Right? It can handle more, it can handle large current. ये यूनिपोलर है ना, और ये बाइपोलर है. These are few of the differences between JFET and bipolar junction transistor, BJT and JFET. Okay. ठीक है? Hello.
Yes, sir.
Okay,
Yes,
I think it's over now. Thanks
Yes,
for
sir.
being with me. है ना?
Thank you, sir.
If you have any questions.